7.5, solve special types of linear systems.
We lost a Portsmouth yesterday.
So, we're going to be looking at special types of linear systems. With this, we can use any method to solve. So it's kind of just going to be a which one's easier. I like elimination, so most of the time I'm probably going to choose elimination, but there are a few of them that might be easier just to go ahead and do substitution. So we may do that on a couple of them for review on that as well. But if a system has no solution, we call it an inconsistent system. I can't spell. Let me try again. S-I-S-T. Consistent. Inconsistent. Okay. System.
You're the one who's doing the top. Stay on lane, Sean. Yeah.
Right, she's literally talking about. I'm trying to.
Yeah. How are you trying to learn if you're not looking at the board?
Bro, because she's writing something down.
Well, then why don't you write it down?
Alright, I'm about to.
Well, go ahead.
Are we done?
Yeah.
Okay. If a system has no solution, that means you get something that is a false statement. Okay? Something that's like 0 equals 4, -7 equals 2, things like that. Then you're going to write no solution, and then you're going to write that it's inconsistent. Okay? Bless you. Consistent and dependent, these things go together, is if a system has infinitely many solutions. Which this would be something that's always a true statement. Like 0 equals 0. -6 equals -6, so on and so forth. So to answer a question like this, if that happens, you would say it has infinitely many solutions, and then you would say it's consistent and dependent. Now, the ones that we've been doing up to this point are called consistent and independent systems, which has exactly one solution. So this is where we end up with a coordinate like -3, 2, or something like that. So they may ask you to classify them. They may ask you just to say how many solutions it has. Looks like they only ever ask you how many solutions it has, so you don't really need to worry about the words. But anyways, the way I remember them, because you will need this when you get to Algebra 2, you do have to be able to say what type of system it is. But independent and, well, consistent either goes with dependent or independent. But independent, you like to do things by yourself, so there's one solution. Dependent, you rely on other things, so there's infinitely many solutions. And then inconsistent is no solution because, it's inconsistent. Anyways. Just another thing here, an inconsistent system that has no solution would be if you had like parallel lines, if you looked at a graph. Consistent and dependent, this would be the same line. If you graphed it, they would be like exactly the same when you graph them. It doesn't mean the equation's the same, but if you think about it, there are some things where the graph is just like, how do I put this? Like a higher, I don't want to say higher powered, but like a, everything was multiplied by 2 when it really is graphing it the same way. It was just a different equation. But that would be like still giving you the same line. And then this one with exactly one solution, like what we had in 7.1, the lines intersect one time. Now, I am not going to require you to do the graphing method. Part of the instructions of one of them says to graph it and then to tell how many solutions it has. But I'm not going to do it that way. Okay? I'm going to do it one of the other ways. The other thing that we can do is, well, I'll just show you without having to solve them on some of them. So with number 8, this is one that says to graph. We're not graphing it, but we're just going to tell how many solutions it has based on what we see about the graph. So we're just going to modify these ones a little bit. We've got x plus y equals negative 2 and y equals negative x plus 5. So I'm going to do a slightly different version here of, instead of solving what we do, and where we could look at the equations of the lines and see it. So with this, I'm going to get y by itself in both equations because I want to see what the equation of the line looks like. So over here, I need to subtract x. So I have y equals negative x minus 2. And then this other equation is y equals negative x plus 5. What do I know about these two equations if I were to graph them? What's going to be true about these? They have the same slope, so what does that mean? They are parallel, and they have a different y-intercept. That's the other key thing. Same slope, different y-intercepts. That means these lines are parallel. Parallel lines have how many solutions? No solution. So I would just say no solution. And I would say parallel lines. What?
Are we ever going to have to graph them?
These ones? No. You only have to graph in 7.1.
7.1.
1. If you want to graph them, you can, but these ones I would just say that say to graph, just find the equation of the line. If they're parallel lines, it's no solution. If it's the same line, and you'll be able to tell, it's infinitely many solutions, and if it's just two lines otherwise, there's only one solution. Those are your only options. 10. 3x minus y equals negative 9, and 3x plus 5y equals negative 15. So all I care about with these ones, I don't care what the solution is. All I care about is how many it has, either none, one, or infinitely many. So I'm going to do this one by getting y by itself and looking at just the equations of the lines. Okay, now we'll do other methods with other ones in a little bit, but we're just going to do these with these. All right, so I'm going to get this top equation. I need y by itself. What do I do?
Subtract 3x.
So I'll have negative y equals negative 3x minus 9. And then now what? Divide by negative 1. So that means y equals 3x plus 9. So that's the first equation. I need to do the same thing over here to get y by itself. So what do I do first on this one? Subtract 3x. So we have 5y equals negative 3x minus 15. Now what? Divide by 5. So y equals negative 3/5 x minus 15 over 5 is 3. So, are these parallel lines? Are they the same line? Nope. So this just has one solution. That's all these ones are asking us for.
So if they're not the same, it's one solution. If they're the same,
Or if they're parallel, then there's no solution. So like this first one, the lines were parallel.
right.
So they have the same slope, different y-intercept. Infinitely many is going to be like exactly the same thing. Negative 9x plus 6y equals 18. And 6x minus 4y equals negative 12. So I need to get y by itself on the top one. So what do I do first? Add 9x. So I have 6y equals 9x plus 18. Now what? Divide by 6. So I get y equals 9 over 6 reduces to 3 over 2. X plus 18 over 6 is 3. So that's that equation. Now I need to get y by itself in this other one. Subtract 6x. So I have negative 4y equals negative 6x minus 12. Divide by negative 4. Y equals, it's going to be positive. 6 over 4 reduces to 3 over 2. X, and then negative 12 divided by negative 4 is positive 3. These are the same line, correct? So that means this has infinitely many solutions. And that's your answer on those ones.
Alright, so I think I got it.
Well, we're not done. Those are just the ones where we're just telling how many solutions it has.
I think I got these.
Okay. All right, so those are under the ones that say graph the system. You don't really need to graph them because we can just tell by the equations. Solve the linear system using substitution or elimination. So we'll just see which one makes the most sense for what they give us. So number 16. And these ones, like if it has like one solution, then we're obviously going to solve for the one solution. If it has infinitely many or no solutions, then obviously we're going to see that pretty quickly. So 16. Negative 16x plus 2y equals negative 2, and y equals 8x minus 1. All right, so given what we have, do you think it would be easier to use substitution or elimination? Substitution, because y is already by itself. Also, just at a quick glance, y and x don't match the y and x up here, so that means I would also have to multiply. So that just looks like a whole lot of work. So I'm going to use substitution. So 8x minus 1 is getting plugged in for y in the top equation. So I have negative 16x plus 2 times 8x minus 1 equals negative 2. And then now we're just solving. So distribute here. I have negative 16x plus 16x minus 2 equals negative 2. Well, negative 16x and positive 16x, that cancels with each other. And I end up with negative 2 equals negative 2. Is that true?
Yeah.
So, infinitely many solutions.
Oh. So you just kind of like combine the equations?
Yep. This is what 7.2 was.
I think I tried doing that yesterday and then I saw that it told me to graph it.
7.2 didn't tell you to graph it.
No, 7.1.
Oh. All right, so once you get to there, you're done. You don't have to do anything else. Nice and easy. 20. X minus 2y equals 7 and negative x plus 2y equals 7. What method do you think I should use with this one? Elimination, because I have same number, opposite signs actually on both things. So combine them. X minus x is 0, negative 2y plus 2y is 0. 7 plus 7 is 14. 0 equals 14. What is that? No solution, because that is a false statement. Those are the easiest ones. Those are my favorite.
Will point 2 kind of be like that?
Huh?
Like 7.2, would that be like this?
No, 7.2 would have been like this one.
Oh, that's easy.
I mean, they have solutions, though. 22. 4y plus 5x equals 15. And x equals 8y plus 3. What method do you think we should use with this one? Yeah, substitution's probably better because, again, nothing already has the same number, opposite signs. X is already by itself. Might as well use that. So I'm plugging in this 8y plus 3 for x up here. So I have 4y plus 5 times 8y plus 3 equals 15. Gonna distribute. So I have 4y plus 40y plus 15 equals 15. Combine like terms here. 44y plus 15 equals 15. Get y by itself. Subtract 15 over 44y equals 0. Divide by 44, y equals 0. Now, take this and plug this into this bottom equation here. Solve for x. So I have x is equal to 8 times 0 plus 3. So x equals 3. And then this one does have a solution, 3, 0.
Is this all it is? This is easy.
Pretty much.
Can we go ahead and do homework?
Almost.
Did you take Algebra 1?
Yes.
You have to.
Do I have to?
Like, do you have to take Algebra 1?
Pretty much, yeah.
See,
You take like half year and you quit.
Huh?
Or like go to another math.
No, you have to like take the whole thing.
Child.
26. Y equals negative 6x minus 2 and 12x plus 2y equals negative 6. Try this one on your own. And you can use whatever method you want.
Wait, is substitution the one like where you combine it?
What do you mean combine
Like,
it?
combine like it together.
Where you plug something into the other one?
Or like say
I'm asking because I think you're using the word in a different sense than I use the word combine, so.
yeah, probably. Like shoot.
So like take the y equals and plug it in for y in the bottom equation.
Yeah.
That's substitution, yeah. Did your brother get you sick?
Huh?
Did your brother get you sick?
No, I'm not sick. I'm just stuffed up. I don't feel sick.
No, I know, I was joking with you.
Wait, Ryan was sick.
Yeah, last week when you were sick.
You
Well,
gave
everybody
it to
was
him.
sick, just what?
Why'd you give technical food or whatever it was?
Bro, he gave that to me.
No, you gave it to him.
Alright.
All right, what do we get?
No solution.
Yeah,
No
no
solve.
solution. Negative 4 equals negative 6.
Yep.
No solution.
Oh my gosh, I'm so smart.
Yep, so I plugged in the negative 6x minus 2 in for y in the bottom equation.
God damn.
When I distributed, I got 12x minus 4 equals negative 6. The 12x's cancel with each other, so you have negative 4 equals negative 6, which is a false statement, so no solution. Let's do 28 and see how we do with this one. 28. Again, you can use whatever method you want. 4x plus 3y equals 27, or 4x minus 3y equals negative 27. So take a minute and do that one. Again, you can use whatever method you want. cow on top is from Hershey World, from somebody in the class of 2024. And then the bottom one is an Easter basket. That's a cow, and I needed it. It's a candy cow.
Wait.
There's candy in the
Hershey
cow.
World. That's a thing.
Pennsylvania.
Where?
What?
In Hershey, Pennsylvania.
I've been
I didn't
Go
even
there
know
on
it
senior
existed.
trip.
I thought Hershey was a chocolate bar.
It is. But where do you think they're made?
Factory.
Where do you think that factory is?
there. Pennsylvania.
Pennsylvania. In Hershey, Pennsylvania, actually.
Wait, it's
And they
literally
pencils
named. It's literally.
I'm sure there's more, but that's the main one.
It's Hershey, Pennsylvania.
Like if you go through the town of Hershey, the lamppost, the top of the lamppost are all Hershey Kisses.
Actually.
Mhm. We did a thing on senior trip. We make your own candy bar.
Wait, you went there?
What'd you put in yours?
Like the Oreo cookie pieces and I think pretzels, and I did milk chocolate. Like it's a milk chocolate bar, and then I did a dark chocolate covering over it that like holds all the stuff that you stuff it with in there.
That's cool.
And I did white chocolate pieces on the inside, like crunched up in it.
That just sounds like diet.
I have an answer.
It was. It took me like a month to eat the. I say it took me like a month to eat the candy bar. I would like break off like a piece at a time and eat it.
This one will be
How big was it?
But you also get like a box with like your name on it that you
Yeah, I
create
did
and
that
stuff.
in
It's
one
pretty cool.
sitting, bro.
I mean, it's not worth the $30-some that you pay to do it, but the school paid for me to do it, so I didn't really care.
I have an
Not my
answer.
money.
All right, what'd you get?
09.
I got it first.
No, you
We
didn't.
agree?
I finished way before you.
Yeah.
So far, and I was like, I'm
Cool.
Yeah.
You're right.
boom.
So this one was already set up, same number, opposite sign, so I could just combine the two things. So I had 8x is equal to 0, divide by 8, so x is 0, and then plug in that to either equation, but I liked the one that had the positive numbers, so I chose the top one. So 4 times 0 plus 3y equals 27. 3y equals 27, divide by 3, y equals 9. Technically, that problem wasn't asking us to solve, but I figured we could use the practice. So, questions?
No, oh, you almost called me Tyler. I don't know. Tyler.
Oh, I forgot to plug in the 0.
Hey, him.
All right, 5 through 7. Those are matching questions. That's just telling how many solutions it has based on looking at a graph. Should be nice and easy. And then 9 through 29 odd. And that sounds like a lot, but most of them. What is happening? What is going on?
I think it's broke.
Is it dead?
Yes. 9 through 2. 9 through 2? Oh, man. Come on.
I don't even know why it's on a highlighter, but whatever. 9 through 29 odd. Let me make sure none of those are weird or have like decimals or whatever.
Isn't 5 through 7 just 5 and 7? Oh, no, because you have to do it. Oh, it's not odd.
Let's say odds only written after 9 through 29.
I'm a little bit.
So most of them are pretty quick. It's just like, obviously, none of these took us a very long time to do. 22 probably took the longest, and that really wasn't even that long. So, shouldn't take you too long. Obviously, it is Wednesday, so if you don't finish, it's not homework tonight, but they are due on Friday. I am assuming that, like, half of you are leaving early tomorrow. Just going on a wild guess. So we may not do the section tomorrow. You may have time to do the stuff tomorrow in class as well. I'll probably wait and just do the other section on Friday if like everyone's here. I have no idea. They haven't even sent out an email about it yet. I literally found out last class period. So anyways, we may have some time to work tomorrow. I'm unsure what exactly we're doing. If you're leaving early, just check in with me and make sure I didn't change my mind. But that's my current plan because there's only one section left and we're like ahead in material. So
We're ahead.
we might have a coloring day. Who knows?
Yay! I like
So anyways, yes.
Yeah, you saw